This journey began some 14 billion years ago, when the Big Bang led to the universe emerging from a hot, dense sea of matter and energy. As the cosmos expanded and cooled, they spawned galaxies, stars, planets, and eventually, life. Good evening, everybody. I am Amin, and welcome back to another video from Be Smarter Daily. In this video, we will journey through time from the Big Bang to the present day, exploring what it might be like if we could travel through these billions of years and gain a perspective on the vast history of the universe. Not much is known about what came before the Big Bang, but we do know that it launched a sequence of events that gave rise to the universal laws of physics and the chemical elements that make up matter. How the Earth came about, and life subsequently followed, is a wondrous story of time and change. Let's look at what transpired after the Big Bang to trace our journey through the cosmos. The Big Bang formed the entire universe that we know, including the elements, forces, stars, and planets. Hydrogen and massive dissipation of heat dominated the initial stages of the universe. During a time span known as the Hadean Eon, our solar system formed within a large cloud of gas and dust. The sun's gravitational pull brought together spatial particles to create the Earth and other planets, but they would take a long time to reach their modern forms. After its initial formation, the surface of the Earth was extremely hot and entirely liquid. This subsequent eon saw the planet cool down massively, solidifying some of the liquid surface and giving rise to oceans and continents, as well as the first recorded history of rocks. Early in this time frame, known as the Archean Eon, life appeared on Earth. The oldest discovered fossils, consisting of tiny preserved microorganisms, date to this eon roughly 3.5 billion years ago. The first era of the Proterozoic Eon, the Paleoproterozoic, was the longest in Earth's geological history. Tectonic plates arose and land masses shifted across the globe. It was the beginning of the formation of the Earth we know today. Cyanobacteria, the first organisms using photosynthesis, also appeared during this period. Their photosynthetic activity brought about a rapid upsurge in atmospheric oxygen, resulting in the Great Oxidation Event. This killed off many primordial anaerobic bacterial groups, but paved the way for multicellular life to grow and flourish. The Mesoproterozoic occurred during what is known as the boring billion stage of Earth's history. That is due to a lack of widespread geochemical activity and the relative stability of the ocean carbon reservoirs. But this era did see the breakup of the supercontinents and the formation of new continents. This period also saw the first noted case of sexual reproduction among organisms and the probable appearance of multicellular organisms and green plants. In some respects, the Neoproterozoic era is one of the most profound time periods in Earth's history. It bookends two major moments in the planet's evolutionary timeline, with predominantly microbial life on one side and the introduction of diverse multicellular organisms on the other. At the same time, Earth also experienced severe glaciations known as the Cryogenian period and its first ice age, also known as Snowball Earth. The era saw the formation of the ozone layer and the earliest evidence of multicellular life, including the emergence of the first hard-shelled animals, such as trilobites and archaeocyathids. The Paleozoic is best known for ushering in an explosion of life on Earth, with two of the most critical events in the history of animal life. At its beginning, multicellular animals underwent a dramatic Cambrian explosion in aquatic diversity, and almost all living animals appeared within a few millions of years. At the other end of the Paleozoic, the largest mass extinction in history resulted in 96% of marine life and 70% of terrestrial life dying out. Halfway between these events, animals, fungi, and plants colonized the land, and the insects took to the air. The Mesozoic was the age of reptiles. Dinosaurs, crocodiles, and pterosaurs ruled the land and air. This era can be subdivided into three periods of time: Triassic, 252 to 201.3 million years ago; Jurassic, 201.3 to 145 million years ago; Cretaceous, 145 to 66 million years ago. The rise of the dinosaurs began at the end of the Triassic period. A fossil of one of the earliest known dinosaurs, a two-legged omnivore roughly 3 feet long named Eoraptor, is dated all the way back to this time. Scientists believe the Eoraptor, and a few other early dinosaurs still being discovered today, evolved into the many species of well-known dinosaurs that would dominate the planet during the Jurassic period. They would continue to flourish well into the Cretaceous period, when it is widely accepted that the Chicxulub impactor, the plummeting asteroid that crashed into Earth off the coast of Mexico, brought about the end of the age of reptiles. After the end of the age of dinosaurs, this era saw massive adaptations by natural flora and fauna to survive. The plants and animals that formed during this era look most like those on Earth today. The earliest forms of modern mammals, amphibians, birds, and reptiles can be traced back to the Cenozoic. Human history is entirely contained within this period, as apes developed through evolutionary pressure and gave rise to the present-day human being, or Homo sapiens. Compared to the evolutionary timeline of the world, human history has risen quite rapidly and dramatically. Going from our first stone tools in the Age of the Kings to concrete jungles with modern technology may seem like a long journey, but compared to everything that came before it, is but a brief blink of an eye.
They'll be calling me royalty.